So I'm back here with one of Archimedes' Principle calculations. This is from worksheet 1.7. This is question 14, and let's start with A. We first have to remember, however, what our formula is, and that formula is a mass minus apparent mass equals the density of the liquid times the volume of the object. And so in this case, what is the object's volume? So I'm looking to solve this for V. And so my formula becomes M minus AM divided by the density of the liquid, this case it's water, equals volume. And so its mass is 57.02 grams minus 40.85 grams divided by 1 gram per milliliter. And now we're ready to calculate. And so in my calculator, I'm going to clear it, and we've got 57.02 minus 40.85, and you have to either use parentheses or hit equals. And now I still have 4 significant figures, and that's why I calculate this number before going on, because now if I divide that by 1, it's the same number, and so my answer should be 16.17 milliliters, because the density here, grams would cancel with these 2 grams here, and we're left in milliliters. Let's look at part B. What is the object's density? This is simple. Density equals mass divided by volume. And so we have to use its real mass, not its apparent mass. And we'll say 57.02 divided by 16.17 milliliters here, grams here. I will be coming out in grams per milliliter, so that's good. And so I'm going to put in 57.02 divided by, and I like to hit this little button down here that says answer. Let me get it slid up enough. I like to use this one. So I hit the shift button, and then I hit answer, and that uses the answer from the previous part. And then I can hit enter, and I get 3.52628 grams per milliliter. This has 4 significant digits. This has 4 significant, so this one has to have 4. So 1, 2, 3, 4. I'm going to stop at that 6. So I get 3.526 grams per milliliter. I did not round up that number because the 2 didn't round it up. So what would it appear to weigh if submerged in alcohol? For that, we need to get the density of alcohol from the worksheet, which I believe is right over here. And that density is 0.718. So the density equals 0.781 grams per milliliter. And so it's going to be, and I need to solve this equation for apparent mass. So I'm going to have mass minus density times volume equals apparent mass. And so 57.02 grams minus 0.781 grams per milliliter times 16.17 milliliters equals. So hopefully you can see enough of that. So 57.02 minus 0.781 times 16.17 equals, and I get 44.391. And again, we're not going to take our significant figures from something I know exactly. So this is going to have 4 significant digits, and it will be grams because milliliters will cancel with milliliters. And so my final answer should be 44.39 grams. So the object appears to weigh 33.17 grams submerged in corn syrup. What is the density of corn syrup? So now we're going to solve that same formula for density. And that would be mass minus apparent mass divided by volume equals density. And so our real mass is 57.02 grams minus 33.17 grams divided by the volume, which is 16.17. I'm running into my tape there, and that's milliliters. Let's see if the pen writes better on there. 16.17 milliliters. So now, to calculate this, let's clear this, it's getting messy. So 57.02 minus 33.17 equals, and now divide that by 16.17, and we get the density of corn syrup should be 1.4749 grams per milliliter. Again, I have 4 significant figures. So I have 1, 2, 3, 4. This 9 is going to round that 4 up, so it's going to be 1.475 grams per milliliter. Okay, I hope that helps. See you later.